Hello students, we'll be learning about squares and square roots, but before we proceed to understand square roots, we'll have to learn about the square numbers. So what are square numbers? Do they look like a square? Do they fit inside a square? No, they are not so. Let's try to understand this by taking a square. We know that squares, they have all sides equal. So we are taking this side to be x. So the other side also should be x. We know that area of a square can be written as side into side. Here the side is x unit, so we can write x into x, that is equals to x square. If we take the side of the square to be in centimeter, so the area of the square would be in centimeter square. So here we have x centimeter, so the area would be x square. If we take x to be 1 centimeter, then the area would be equals to 1 into 1, which is equals to 1, which can also be written as 1 square. 2 centimeter, then the area would be 2 into 2, that is equals to 4, which can be written as 2 square. We have 3 centimeter, then the area would be 3 into 3, that is equals to 9, which can be written as 3 square. We have say 4 centimeter, then the area would be equals to 4 into 4, that is equals to 16, which is written as 4 square. So from these examples, we can write 4 can be expressed as 2 times 2 or 2 square, 9 as 3 times 3 or 3 square. So such numbers like 4 and 9 can be expressed as the product of the numbers with itself. So in general, if a natural number m can be expressed as n square, where n is a natural number, then m is called a square number. So let us see, 12. Is it a square number? We'll try to find out this. We know that 3 square is 9 and 4 square is 16, and we know that 12 lies between 9 and 16, so it must be a square number between the natural number 3 and 4. But 3 and 4 are natural numbers, and in between this there are no other natural number, because 3.5 is not a natural number, it's a decimal number. So there are no natural numbers between 3 and 4, so we can say that 12 is not a square number. Let us take another example to understand this better. Let's say 44. Is it a square number? We know that 44 lies between 36 and 49, which is 6 square and 7 square. If 44 has to be a square number, then it should lie between the number 6 and 7. But we know that there are no natural numbers between 6 and 7. So we can say that 44 is not a square number. So we conclude that the numbers like 1, 4, 9, 16 are square numbers because they can be written as the product of natural numbers. These numbers are also called perfect squares. Look at this table here. This table is the square of numbers from 1 to 20. We have 1 square to be 1, 2 square as 4, 3 square is 9, 4 square is 16, and so on. We'll try to understand the properties of square numbers. Let us take the square numbers from 1 to 100. We know that 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, and 10 square is 100. Let us have a look here. In the units place of 1 and 9, the square of 1 and 9. We have 1. When we square 2 and 8, the units place is 4. Likewise, when we square 3 and 7, the units place is 9. And when we square 4 and 6, the units place is 6. And when we square 5, the units place is 5. Now, when we square 10, the units place is 0. Let us understand this by taking the squares of 11 till 20. Again, let's consider their units place. When we square 11 and 19, the units place here is 1. And when we square 12 and 18, the units place is 4. Likewise, we have 9 here, we have 6, and we have 5. Likewise, when we square 20, the unit place is 0. Here, the unit place ends with 0. None of the perfect square numbers end with the number 2, 3, 7, or 8. All of them ends with the digit 0, 1, 4, 5, 6, or 9. Have a look at the table once again. We don't find 2, 3, 7, or 8 when we square any number. So we can conclude that if a number is ending with 0, 1, 4, 5, 6, or 9, then the number may be a square number. Let us take this table again. We'll try to understand another property here. We have 1, 3, 5, 7, and 9. What are these numbers? They are called odd numbers. Let us have a look at the square of these odd numbers. 1 square is 1, 3 square is 9, 5 square is 25, 7 square is 49, 9 square is 81. So, the square of an odd number gives us odd numbers. Let us consider 2, 4, 6, 8. These are even numbers. When we square them, we get 4, 16, 36, and 64. And these are nothing but, again, even numbers. So from this example, we can see that the square of odd number will always be odd, and square of even number will always be an even number. This is another property of square number. Let's try to understand another property of square numbers. We have taken a square, we have taken numbers. 1. Square of 1 is 1. Square of 9 is 81. Square of 11 is 121. Square of 19 is 361. Here in the number side, the units place ends with 1 or 9. Then the square of such number will always end with, or the units place will be 1. Let us take another example. Suppose we have the number 4, we have the number 6, again here 14 and 16. Here the numbers are ending with the digit 4 or 6. Then the square numbers will end with the digit 6. So this is another property of square numbers. Let us take this example to understand another property of square numbers. 10, 20, 30, 40. When we square them, we get 100, 400, 900 and 1600. Here on the number side, we have only one zero. When we square them, the zeros double. Likewise, 100, 200, 700, 800. In the number side, we have two zeros, and when we square them, it becomes four zeros or simply double. So, what if there are three zeros? How many zeros will be there after squaring? We know that the answer is there will be 6 zeros. So the number of zeros will double. So we can conclude that the number of zeros will double. So if it is 50, then there will be two zeros after the square of 5, that is 2500. Okay, what if someone asks you how many non-square numbers are between two given consecutive square numbers? Can you see the answer? Okay, let's try to understand this. This is also another property of square numbers. I have taken the square of 1 as 1 and the square of 2 as 4. So 1 and 4 are the two consecutive square numbers. Let's understand this. There are numbers 1, 2, 3 and 4, meaning 2 and 3 are the numbers between 1 and 4. So there are two numbers between 1 and 4. Let us take the consecutive square numbers 4 and 9. So between 4 and 9 there are 5, 6, 7 and 8, meaning there are four numbers between the consecutive square numbers 4 and 9. Let us take another consecutive square number 16, that is 4 square. So between 9 and 16 there are 10, 11, 12, 13, 14 and 15, meaning there are 6 numbers between 9 and 16, which are consecutive square numbers. Now, if you are given bigger number, then you will have to write all the numbers between them to answer that person. So let's make it easier by understanding this or understanding the pattern here. So between 1 and 4, if I take the larger square, minus 1, minus 1. 4 minus 1 is 3. So it becomes 3 minus 1, and 3 minus 1 is 2. We know that 2 and 3 are the non-square numbers between 1 and 4, that is, there are two numbers. Likewise, the second one, so there are two non-square numbers between the square numbers 1 and 4. Let's take the second one. The larger square is 9 minus 4 minus 1. So 9 minus 4 is 5. 5 minus 1 is 4. So there are four square numbers between 4 and 9, that is 5, 6, 7 and 8. Likewise, the last one, the larger square number is 16 and the smaller one is 9. So 16 minus 9 minus 1. 16 minus 9 is 7. 7 minus 1 is 6. That is, there are 6 numbers between 9 and 16. So 10, 11, 12, 13, 14 and 15 are the non-square numbers between 9 and 16. So from this we can derive that non-square numbers between two consecutive numbers can be found out by simply subtracting largest square number minus smaller square number minus 1. So this formula can be taken, or this formula can be used to find out how many non-square numbers are between two consecutive square numbers. Let us understand another property of square numbers, that is sum of consecutive odd numbers. Do you know the meaning of consecutive? It means it comes one after another. For example, 1, 2, 3, 4, 5, these are consecutive numbers, natural numbers. If I take 1, 3, 5, 7, 9, 11, likewise, these are consecutive odd numbers. If I take 0, 2, 4, 6, these are consecutive even numbers. So let us take the first odd number 1. This is the one odd number. If I add 1, I'll obviously get 1, which can be written as 1 square. If I take 1 and 3, these are the first two odd numbers. If I add them, I get 1 plus 3 equals to 4, and 4 can be written as 2 square. Let's take first three odd numbers. Then 1 plus 3 is 4, and 4 plus 5 is 9. 9 can be written as 3 square. Let's take another consecutive odd numbers, that is 1 plus 3 plus 5 plus 7. That is the first four odd numbers. 1 plus 3, 4, 4 plus 5 is 9, 9 plus 7 is 16, and 16 can be written as 4 square. Likewise, if we take the first 5 odd numbers, then I should be getting 25, that is 5 square. If I take first 6 odd numbers, 6 square is 36. So without adding also, we can easily find out the total sum of any consecutive odd numbers. So we can derive the formula as sum of first n odd numbers, where n is the odd number of odd numbers, can be written as n square, where n is the number of odd numbers. So if there are 10 odd numbers, 10 square is 100. So we can easily find out the sum of any consecutive odd numbers. Thank you for watching this video. I hope you understood the properties of square numbers and you understood what are square numbers. You can easily now solve questions related to square numbers. I'll be uploading the second video soon for your reference. Thank you.